Well, today our lecture is about urban geography, and I thought we would start out with a map of the metropolitan statistical areas of the United States, because one of the things we'll be talking about is that you have kind of, it's almost like Russian dolls, different levels of nesting of cities. You have the legal city, um, and then like suburban sprawl, and then the metropolitan statistical areas, which are really clusters of counties. So that's why you see a lot of geometric boundaries on the map, because they're defined by counties. And we see that a lot of the United States, particularly the eastern half of the United States, is covered with counties. It doesn't mean that all these areas are completely developed, because at the end of this presentation, we'll see that actually only 3% of the land area of the United States is actually urbanized in the sense of having a house, an office building, or a road covering it. Only 3%. Yet, because of commuting fields, obviously a substantial part of the United States is within the orbit. If you think of a city as a magnet, and every city has like a magnetic field that attracts people in to work and for shopping and hospitals and airports and all that. Those metropolitan areas cover a lot of territory, even though a lot of it is still woods or farmland in a sense. About 10 years ago, the census folks also started designating a smaller area called micropolitan statistical areas. I mentioned that especially because there happens to be a lot of those in Ohio. So like um, Zanesville is a micropolitan area, and Athens is a micropolitan area, and Marietta. It's basically a miniature statistical area. It's largely one city or town like Zanesville with its one county. So in Zanesville's case, it's Muskingum County. In Chillicothe's case, it's Ross County, and so forth. And when you add in, since there's about 600 of these micropolitan areas, to be a metro, you have to have a core city of 50,000 people. So that would be like a Dayton or an Akron or a Canton. Whereas to be a micropolitan area, you have to have just 10,000 people. And once you add in the micropolitan areas, it looks like, almost the entire eastern half of the United States, except for some areas like the Appalachians and far northern Maine, are covered with some type of urban area. But, it makes sense, because no matter where you live in the United States, you're within commuting distance of, a center that is at least that size. Everybody has, say, within an hour, pretty much access to a hospital and a shopping mall and so on. That would be in an urban area. If we look in particular at Ohio, we see the metropolitan statistical areas. Of course, we have the big three, the three C's, right? Cleveland on the lake, Columbus near the center of the state, Cincinnati in southwestern Ohio. And then we have others, and we'll see that my cursor appears. Yes, we have Toledo. We have places like Lima. Springfield's a separate area. Dayton's separate from Cincinnati. In southern Ohio, Lawrence County, which by itself is a small city of Ironton, where OU has a branch campus, but basically it's part of the metropolitan area of Huntington, West Virginia. Then we have Parkersburg and Marietta. Then we have up here Youngstown in the blue, and then Akron, Canton, and Cleveland. And what happens then is that these metro areas start growing into each other. So actually Cleveland Cleveland, Akron, Canton is considered a single metropolitan area, a combined metro area. And you also have the complexity that these metro areas expand across state boundaries. So actually Cincinnati includes quite a few people, and it's not quite a million, but over in northern Kentucky, just as Huntington, West Virginia, lops over into southern Ohio and includes Lawrence County, and then Parkersburg, West Virginia, lops over the state line and includes Marietta in Ohio and Washington County. So you have the complexities. We'll see when you talk about what's the size of a city. You have quite a bit of complexity to that question, and we'll see that. Here's a map of the urbanized areas, which doesn't show all those county boundaries. So once you take away the county boundaries that represent basically the commuting fields, you get a little bit better idea why I said earlier that only about 3% of the territory of the United States is actually, urbanized in the sense of densely built up. And we do see, and we'll see this several times. And I also want to say, I'm kind of talking mainly about the United States because we're more familiar with it, of course, but I also want to give you some examples from outside the United States. But as we'll see as we go along, we have the kind of the original megalopolis, it was called. This term was coined in the 1950s by actually a French geographer who was visiting here. And he wrote about the fact that basically this strip of cities from Boston to Washington, this is Richmond here, but Washington, D.C., Baltimore, Philadelphia, New York, and Boston had grown into one giant city called megalopolis. Basically, their boundaries had spilled over into each other. And over time, others have developed. So you can talk about a megalopolis that's in Florida. You can talk about one that's in Texas, this kind of triangle of Dallas, Fort Worth, which itself is two cities grown into each other, Houston and Austin. And then you have other megalopolises, or I guess you'd say megalopoli, in Southern California, around LA. You make a case for one in Northern California, and then you can make a case for one in Seattle, Portland on the West Coast, although they haven't grown together as much. You see all that empty space in there as is the case on the East Coast. And you can have one with different definitions. You can define one around the Great Lakes, like from Cleveland to Detroit to Chicago, Milwaukee, and so on. Another way to think of those urbanized areas, and you can see a lot of these on the web if you're interested, but look for these nighttime views. These are satellite photographs of what places look like when they're lit up at night. And some of them are real photos, some are kind of artificial photos where they've patched things together to make it look like, this is what those cities would look like at night and so on. But anyway, these are real ones, and you can see it is true that the eastern half of the United States is certainly much more densely populated, and we know that, than the western half. Basically, there's not a lot other than in the west, other than Denver and Salt Lake until you get to the west coast. But think of it that way, that these urbanized areas show energy use, they show where people live. We'll see a world map in a second, and it's, to a large extent, you can almost define that as a measure of economic development. We talked about several measures of that when we talked about economic geography, and but one of the most simple measures of economic development and how big your economy is and how much money that area has, and then in turn those folks who have the money are then wealthier and so on, is just look at the planet at nighttime and see who has the lights on, because all of the world these days runs on electricity. And this is a good map because you see very clearly back to the idea that that East Coast strip from Boston to Washington is almost grown into a single city. You see that pretty clearly. You also see there's quite a cluster around the Great Lakes in Florida, and then on the West Coast as well. And it's not just the U.S. This is Europe, North Africa, Russia is here. This is Moscow right there. But you see that, like in the United States, when you come over to England, northern France, Germany, and what are called the Low Countries, Netherlands, Belgium, Luxembourg, that area, those areas are very densely populated, very industrialized, a lot of electric use, a lot of lights. You also see an interesting thing in Europe around the coast of the Mediterranean that, why are all these lights here? Because that's where the denser population is, right along the coast. And you see in places like Scandinavia that very much they are also clustered along the coast as well. This is Norway here. This is Sweden. So this would be Stockholm. That would be Oslo, and so on. So these folks are clustered in all these cities. And you see certain clusterings, like this is the Nile River. Look how much, this is in Egypt. Look how much closely dense population, and in turn, lights at night follows the Nile River. And then you see some of the oil-rich countries along the Saudi Arabian Peninsula and so forth. This is the world map of urbanization, and pretty much all the brightest lights we've talked about already, which is, the United States lopping over into Canada, and Europe on into Russia. Then, of course, we have Japan, and quite a bit of development now in China, particularly along coastal China and southern China. Some in India. But if you go to the southern hemisphere, remember the north-south analogy, there's a lot more economic activity going on in the northern hemisphere than the southern hemisphere. We see a few areas. And actually, of course, here in northern South America, we're actually still in the northern hemisphere because the equator cuts through right about here, almost at that whitest point of South America. But you do see a lot of urbanization this is southern Brazil, and then again in Argentina, particularly around Buenos Aires. South Africa, such as Johannesburg, Cape Town, and so forth, and then again in Australia. Mostly on the east coast of Australia, Brisbane, Sydney and Melbourne, Melbourne and Sydney, and Perth, which is on the west coast of Australia. New Zealand doesn't show up very much, although their city assemblies aren't as big. They're like 500,000 rather than 10 million or something. But the point is that nighttime lights are a good indicator of urbanization. Urbanization reflects, to a large extent, the level of economic development in a country. And you see that I put this map up. It says the same thing, but it made the point because it had pretty colors. But in this case, your level of the highest levels of urbanization are shown in red, and orange are the highest level. This particular one, this goes back to 89. So actually, it kind of implies that the United States is not as urbanized. The United States is about 81 or 82% urbanized. We still have some rural population and so forth, but in fact, in some countries like Brazil, so many folks have moved into the cities. You might say, well, why is Brazil more urbanized? It's actually now about the same. But the point is, there's not a lot of folks like in the Amazon rainforest. There's while there's a lot of development going on, there's not a lot of people. The vast majority of the people live in the big cities. You see that in Australia. You see that Russia and China are about not as urbanized as some of the others. But this map is particularly useful to look at like Africa and India, because you see that they have much lower levels of urbanization. In fact, some of these countries, less than 20% urbanized in Africa, and so on. Yet we also see that this map, now the darker colors show what countries are most rapidly urbanizing, and they are in Africa, because when you have, don't mind the analogy, I mean, if you get a 20 on an exam, you could, with a little bit of studying, you could double your grade, right? What I mean is, if you have a very low level of urbanization, it's those countries that are experiencing the fastest level of growth. Once you're at 80%, you already have an A on the exam, or a B or whatever. It's much, much harder to get, if you scored a 93 and you want to get a 95, you're going to spend hours and hours studying. So it's the same analogy. The countries with lower levels of urbanization are the ones that are growing most rapidly. Of course, there's not a lot of work for folks in these cities. They leave a poor rural area and you come to a poor urban area. You're still poor, but the old thing, there's an old expression about how you're going to keep them down on the farm once they've seen Paris, meaning Paris. Folks would rather be, if you're going to be poor, you may as well be in the urban area rather than in a rural area, since in theory anyway, you have more opportunities to get a job or whatever. Excuse me. We talk about the term, geographers talk about the term primate city, which means the primary city. And there's different ways to define it, but it means that a lot of countries have one big city that tends to dominate everything. It dominates their economy, it dominates their politics. In many countries, it's the capital. And some people say, well, that city should have 20% of the population, or 25%, or 30%. But it also often means that, so anyway, a big chunk of the country's population. And secondly, a lot of times when this occurs, there's not a very big second city. So if we look at the first example, metropolitan London, I just use capital M for million. 14 million people in metropolitan London. All of England, or the United Kingdom, only has 64 million, so that's 22%. In Manchester is the second largest city. It only has 2.5 million people. Metropolitan Paris is a second example. It's funny, we'll see there's some mathematical regularities in city size distribution, but it's funny how, very different country, France, right? It's almost got the same set of figures. Instead of United Kingdom, 64 million, France has 66 million people. Instead of London having 14 million, Paris has 13 million in its metropolitan area. So in this case, it's 20% versus 22% in England. Lyon is second with 2.2 million people. So when I say there isn't a close rival, I should probably go down to the bottom of this, because one of the things I'm leading up to saying is that no matter how big we think New York is not a primate city. It doesn't have close to, even though it's got 20 million people, and there's different ways of defining what the boundaries of New York City are, but let's say 20 million people. The United States is almost 320 million people, so it's only 6%, so it's nowhere near the 20%, the 25% used to say, well, it's a primate city. And it does have rivals, because New York has 20 million, Los Angeles is 13 million. It's not impossible that someday in your lifetime that maybe LA will have more people than New York. Chicago has about 10 million. Even if, when we're talking about megalopolis and that strip of cities from Boston to Washington, even if you add that all together, you said, as some people have said, well, really, that entire megalopolis strip is the United States does have a primate city. It's that whole megalopolis strip from Boston to Washington. And it makes sense because now you've got, that primate city has like everything. So you've got, the financial capital of the United States in New York. You've got the political capital in Washington. Combine it all together. Even if you do all of that, you only end up with about 50 million people. I mean, it's a lot, but it's still only 15% of the population. And to some extent, you could make a case that having a primate city means your country is not fully developed yet, because that's what happens a lot with you get these primate cities a lot in colonial countries, where like Lagos, Nigeria has 20% of the population, because it hasn't spread out yet to the rest of the country. In the United States, it has spread out to the rest of the country. New York City does have rivals, where you've got, other cities that are 2/3 as big, and so on. Back to these secondary cities, Manchester with 2.5 million is small potatoes compared to London's 14 million. Lyon with 2.2 million is small potatoes compared to Paris's 13 million. Other examples of primate city are metropolitan Tokyo, and actually that's a cluster where Tokyo and Osaka have grown together and so on. So it still has a primate city. Lima, Peru is an example. 10 million of the 30 or so million people in Peru live in Lima. La Paz, Bolivia, where I showed you the photo of the cable cars, 2.3 million out of 10 million, so that's 23%. A very good example is Seoul, South Korea. Almost half the population of Korea lives in that one metropolitan area. So anyway, that's called a primate city, or think of it as meaning like primary city. And if you don't have a single primate city, it is interesting to note, though, that in many countries, and some of the most developed ones, a few cities make up a lot of the country's population. So Canada, remember we talked about it being its population distribution is like a shoestring country, because it's all, 90% within 200 miles of the U.S. border and 80 or so percent within 100 miles of the U.S. border. But in addition, the population is extremely clustered in just a few metropolitan areas. And in fact, you don't get half, but you get 40% of Canada's population are in metropolitan Toronto, 7 million, metropolitan Montreal, 4 million, metropolitan Vancouver, 3 million. Canada only has 36 million people. That's about a tenth, less than a tenth, no, a little more than a tenth of the United States population. Another place that happens is Australia. Australia has 24 million people. Again, in this case, definitely less than a tenth of the U.S. But half or more are in 4 metropolitan areas. Sydney with 5 million, Melbourne 4 million, Brisbane 2 million, Perth, which is on the far west coast of Australia, 2 million. So you add those up, you get more than half the population. So that's how clustered these folks are in a few very large urban areas. I took the example of Cleveland to kind of show what I mean about these varying definitions of what's a city. The first map on the left in red shows official boundaries of the city of Cleveland. They vote for the mayor of Cleveland. If you live there, your kids, if they go to public school, go to the city of Cleveland Public Schools. But as you know, over time, the city has spread out so that the urbanized area basically has spread to almost all of this block. Okay, we've expanded out from this here, the red area, and you see the rest of it in white. Here you see the urbanized area, and basically it's all pretty much urbanized within this regions, primarily Cuyahoga County, except for the lands that have been left in parks. And so the white spaces would be areas that are not really urbanized. Now, it doesn't mean that, again, literally this is all built up in buildings. A lot of these may be suburban neighborhoods with houses on 1 acre. So it's not, remember, it's not all covered in buildings. You can have a lot of greenery and so on left within these areas, right, oftentimes right in the city. And here's a satellite photo of Cleveland showing the urbanized area. If you want to think of it this way, the urbanized area extends beyond just the city limits. And it's a way, if you were an alien in a spaceship up there at night and you were trying to draw a city, or in the daytime, as this satellite photo shows, you'd say, well, this area here, you take your pencil and say, I'm going to include that, but this isn't developed, so I'm going to draw it over here, and it comes out here along this highway, and then it goes back along the coast and so on. What that urbanized area is trying to show is the most densely built up area. And another way of figuring that out would be to look down on the city from high altitude and draw a line around the most densely built up areas, or do it at night, the areas where you see the most light. So that would be the urbanized areas. Then the next level out would be the metropolitan area, which is defined by clusters of counties. So now you start including a lot of edges, a lot of undeveloped land, pasture land, forests, and so on along the edges of this. But within these counties, a large number of people, and this is Cleveland, Akron, Canton, commute in, either not necessarily to the center of the city, because you might be commuting into, maybe you work at a suburban mall, but the point is you drive inward toward that magnet, right? And this is what, in fact, in an urban area, you can get what the textbook calls the wildland interface, right? Right. Some folks are part of the city, but they're right on the edge of the forest and so on, and literally, might have deer in their backyard and so on. And defining these city populations, I don't want to say it's tricky, because it's not that it's tricky, because you can get figures down to 207 people, exact figures, but in casual conversation, you might people say, well, what's the largest city in Columbus? You can get different answers depending on what question you're asking. Clearly, in the legal sense, Columbus is the largest city, because it has 823,000 people in the legal city in terms of who votes for the mayor of Columbus and goes to Columbus Public Schools. But in the urbanized area, if you fly over at night with your pencil and start drawing the map, actually the urbanized areas of Cleveland and Cincinnati are actually both bigger than Columbus. But then when we switch to talking about the metro magnet, so to speak, well, once again, Columbus has actually, easiest thing to say would be it turns out all three metropolitan areas are approximately the same size, because it only ranges from 2 million to 2.3 million difference. But in the way the Census Bureau defines it with the combined metros, Cleveland is the distinctly largest city. since it is a metropolitan cluster of about 3.5 million people, whereas Cincinnati has about 2.1 million people. Now Columbus is the same, but it's not combined with anything, so it's not defined as a combined metro. But it would then be second before Cincinnati, and then you get the complexity of, yeah, well, Cincinnati has let's call it 2.2 million people, but remember, slide jumped ahead, but remember that only 1.6 million of those are actually in Ohio. So another complexity you get into is, you can define Cincinnati to be larger than Columbus. However, don't forget, it's because Cincinnati is counting 1.6 million people who live in Kentucky. So, by the way, that's one of the things about having rivers as boundaries, because rivers are state boundaries, and pretty much all big cities are on rivers. And so you build bridges. Almost all your big metropolitan areas overlap states when you think of it. Whether it's, Kansas City spilling into, actually the big Kansas City is in Missouri, not on the Kansas side. Anyway, big metropolitan areas, I don't know if it's fair to say almost always, but usually overlap state boundaries, which creates complexities in things like regulating, well, anything, charging a toll, or regulating air pollution or water quality or school districts or whatever. Geographers talk about Christaller's central place theory. There's another German geographer like von Thunen. I think von Thunen was Friedrich. This guy was Walter Christaller. He was a German geographer, and he came up with what he called his central place theory. And Christaller tried to explain why different sized cities developed in different places. And what I want to do is think about Iowa as a place, because he wasn't talking about the obvious. I mean, you might say, well, yeah, you can go around the country and say, well, this city developed because it's a coal mining area, and this city developed because it's a fishing port, and this city developed because it's a military base, and that city developed, Orlando, because it's a tourist attraction, and this city developed because it's a college town. So Walter Christaller said, forget all that. Let's go to what he called an isotropic plane. You don't have to know that term, but what he meant was just a flat Nowheresville, so to speak. No offense to anybody in Iowa, but where you've got an area where there aren't obvious reasons. Because if you look at Iowa, you find the same type of thing happen, which is you have little villages here and there, and then another, a smaller number of towns, then a smaller number of bigger towns and cities, and a smaller number of metropolitan areas. Why did that develop in Iowa? Because you can't say, well, it was a coal mining town because there's no coal there. You can't say it was a fishing village because there's no fishing, there's no seaport there. And what he said, basically, he used he based it on the idea of hexagons. You get hexagons. Remember the thing about every little village, city, and town is a magnet. And it attracts people, in theory at least, from the closest areas. Because you go back to the days of people, farmers walking places, and horses and buggies and so on. They were going to go to the nearest town. So if you wanted a pair of shoes, you were going to go ride your horse into town 5 miles. You weren't going to go 11 miles to the other town. You were going to go to the closest town. So he assumed an equally distributed population, and he assumed that people went to the closest place. And what he said, we start with the diagram on the left, is that you develop these little towns, actually the smallest red dots here, and that the hexagons would develop because if you had simply circles, you would either have to have overlapping circles or you would have uncovered spaces, right? If you have a bunch of rings and you stick them together, right, you get little uncovered spaces in the middle. So if you, and you can actually do this as a physical model, you can take like cardboard tubes, and if you squish them all together, they compress down into hexagons, like a beehive. So he said that in general, for every 6 hexagons, because let's switch over to the larger scale on the right. What happened to my cursor? There it is. Let's take a look at this red city, right? It is serving, Christaller's argument was, whether you see that red circle on the right-hand diagram, that city develops to serve get my cursor back, I'll show you. Let's take this yellow one. Whatever stuff is going on there, a restaurant, a barber shop, a post office, is serving not only the local people who live within the orange circle, but the 6 hexagons around it. So it's serving 7. Itself, this hexagon, and the 6 around it. And you keep getting higher and higher layers. If we go back to this diagram, so this city is serving its hexagon and the 6 around it. But that makes a new hexagon. And this city in the center is serving that giant hexagon now, plus the ones around it. So you keep going up, and this is what's called the urban hierarchy. It means and you can give them different names. The map on the right says village, market town, then a larger town, and a city. And you have different levels or orders of functions. And I'll explain those terms. The function simply means the variety of stuff that's offered. The best way to think about functions is to count categories in the yellow pages. I know nobody uses the paper yellow pages anymore, but you can see them on the web. Count categories of yellow pages. How many different functions or services? Think of functions as being the same word as like services. And then the levels of cities are sometimes called orders. Geographers will talk about a first order city as meaning actually the lowest level of city. But anyway, if you look at some to get the idea, I mean, and you know this just from driving around Ohio or wherever you live, because it's true all over. You have these little tiny places, let's call them village. And it's got a quick shop, and across the street there's a gas station, or maybe the quick shop is also the gas station. There's probably a church. There's just 2 or 3 little clusters of things. Maybe some place sells pizza or something. But a little farther away is a market town. Now, each level has everything below it. So, of course, the market town has a quick shop. Of course, the market town has a gas station. Of course, it has a church. But in addition now, it might have a restaurant. Maybe this is just like a lunch counter type of place. Maybe it has a dry cleaners. Maybe it has a post office, has a barber shop, hairdresser, probably has auto repair, and so forth. That's a higher level town, if you think of it that way. And then for every 7 or so of these market towns, and so you're going to have that one market town is going to serve the people from 6 or 7 villages around it. Then every time you have 6 or 7 market towns, you would have a larger town that's now serving. So think of it this way, you keep multiplying by 7, right? So now we got like this town is now serving about 50, theory 49, 50 villages and the populations of the 7 or so market towns around it. So now you've got lawyers, a library, drugstore, hardware store, funeral home, used car dealer, and so on. And you work your way up to city. Same thing. Now this city is serving the 7 surrounding towns, the 49 surrounding market towns, and whatever 7 times 49 is, 350 little villages all around the area. So you have a Zanesville, for example, with smaller places around it, like Dresden and Philo and can't think of all. Cambridge is almost the same size as Zanesville, but New Concord and so on. In a city now, so let's say we're talking about the size of Zanesville, now has not only restaurants, but now you get a specialized restaurant. So now you have your choice. Do you want Italian? Do you want Mexican? Do you want Chinese? Jewelry stores, music stores, hospitals, florists, new car dealers, as well as used car dealer and so forth. And as I say, the one way of thinking about this is that you're counting categories in the yellow pages. And as you work your way up, if you want to, buy a fur coat, right? You're probably going to end up going to Columbus. And so on, all the way up the urban hierarchy. The more specialized things are, the larger the number of people you need to keep that business afloat. If you're in the business of selling antique oil paintings, you're not going to be located in Cambridge, Ohio. You're going to have to be in a bigger city that serves more hexagons. So that's the whole idea of Christaller's central place theory and the levels of cities. Because of that stuff about the 7, there is some evidence that these market areas mathematically tend to be hexagonal. It turns out that it becomes somewhat mathematical, and you can take anytime you can make something into a straight line on a graph, it means there's a formula for it. And geographers also talk about what's called the rank size rule. And I'll explain that on the next slide, but I just wanted to show you a graph first. And to again emphasize that once you can show a straight line, and this happens to be what math people would call a logarithmic graph, log graph, but we don't have to get into that. The point is when you can put something into a straight line on a graph, it means there's a formula for it. They call this the rank size rule because the size of the city and the rank of the city is at the 5th largest, the 10th largest, the 17th largest. And someone named Zipf, I think it was George Zipf, maybe, this was probably in the 40s, started developing this idea of this mathematical formula. And he said, gee, and it works out in a lot of countries. He said, to demonstrate how this formula works, you can take the population of the country's largest city, let's say it's 10 million, and divide it by its rank. So let's say pick 5. What's the size of the 5th largest city? Well, it turns out you divide the 10 million by 5, and it said, it's probably going to be about 2 million. The 5th largest city should have about 2 million people. If your biggest city is 10 million, your 10th largest city should have about 1 million people. It works in reverse too, and you can read that if you want. But somebody says, "Well, my country, my city I come from is the 20th largest city. We have 300,000 people." And you can say, "Oh, okay, 20 times 300 is 20 million." No, 20 times 300,000 is 6 million. Your largest city must be about 6 million. Now I'm exaggerating because it doesn't always work that well. Then you have the complexity of primate cities. If you go back to that graph with the straight line, you still have a regular line, and I shouldn't say straight line. You have a line. It'll be a wobbly line. What happens if you think of it this way in the primate city distribution, you still got the line, but the second, third, and fourth dots are missing. The biggest city, the primate city, has pirated that stuff away. It's defeated its rivals. For nobody is challenging it to be the second largest, to be the largest city. So you still have a relative line. It's just that those dots are missing, and so Lyon and Manchester are on there, but there's a big gap between here's London, there's nothing, and then the line picks up again. That's what happens with the primate city distribution. But it's just interesting to think that there is some mathematical order to this, because you have millions of these towns all over the world, and the same principles are in operation, which are people want to go to the closest place to save time, whether they're walking, driving, or on horseback, and you get these mathematical regularities developing out of them. Well, the three models we're not going to spend a huge amount of time on the models. I just want to kind of tie it together a little bit together. The reason I say we're not going to spend a huge amount of time is you saw it in the textbook. You saw some videos about it. But so I'll just wander through them briefly and try to summarize it or tie it up a little bit better than you've seen so far, I think. The Burgess concentric zone. The concentric zone means rings. Concentric means rings. Has a central business district in the middle, in the center. All these models have a central business district. It's the same thing we call downtown. It might be a big downtown, or it might be a skyscraper downtown. Excuse me. It might be a small downtown like Zanesville downtown, or it might be a big downtown with skyscrapers and so on. But particularly in the American context and a lot of the world, originally you had a zone of factories around the downtown, and then you had the lower economic class residential, because made perfect sense in those days. First of all, the rich people didn't want to live near the factories, and secondly, the poor folks could walk to work or take a trolley car or something in those days, or a bus. So they were close to the factories. And then farther out, you had the medium class residential, and then farthest out, you had the high class residential. So you had these different sectors, and we'll see. There's always levels of complexity to it, but to some extent, this is still generally true that you're lower income, you're buying a house, to some extent. These houses might be a little bit cheaper than the more expensive houses. And of course, sometimes it's tied in with the fact that you're also buying more land out in the suburbs, so to speak. Whereas you have almost no very tiny lot. You don't even have a quarter acre. If you're in here, all you've got is an apartment, perhaps, or maybe a house on an eighth of an acre or something like that. That was the Burgess model. This was Hoyt's sector model. And he said, no. Burgess doesn't know what he's talking about. The city isn't structured in terms of rings. The city is structured in terms of wedges, which are more like slices of pizza. And he said, because the thing, back to the Burgess model for a second, you say, well, yeah, that makes some sense. Obviously, the CBD, the downtown is downtown, and there's warehouses and factories around it, and lower income folks live there, and generally the higher income people live on the outer ring, and so on. So It makes some sense. And then Hoyt comes along, and you probably say, yeah, this makes some sense too. He said, well, actually, what happens, these sectors develop along transportation corridors. So you have a railroad and heavy truck traffic and so on. That's going to be a low income sector. They can't read it, but it says disamenity. Amenity means nice things. So disamenity means unnice things. And you do indeed find in cities, because my point about this is you're probably going to say, yeah, that makes some sense too. You have sectors of the city that have lower income folks, sectors of the city that have higher income folks. Again, it has a CBD. Then, of course, you have middle class people who are trying to get away from the lower class neighborhoods and try to get close to the upper class. So you have the middle class next to the upper class, lower class on the other side of town. Think of it this way. The reason this makes a lot of sense is we do have these transportation corridors. And this disamenity that has this zone had the railroad tracks. So let's say we're looking at this one here in the northeast corner of the city. This one. And it had railroad tracks coming in, factories, a lot of truck traffic. They put a gas pipeline in. So land values weren't, if you were looking for a place to build a house, if you're relatively poor, well, this is the place you can afford a place, right? A place by the railroad tracks, right? The upper income people are not going to live by the railroad tracks. Their windows shake when the train goes by. But that kind of feeds on itself, and then you get, well, we got to put a dump somewhere. Where are we going to put it? Well, we're not going to put it in the upper income neighborhood. Those folks will not allow it. It's not going to happen. Because of they contribute money to who ran for mayor, and the last thing that's going to happen is that those upper class folks are going to let the dump be put in their neighborhood, and they're not going to let the prison go there, and they're not going to let the sewage treatment plant go there. So you have these corridors of disamenity that develop along the low income corridors, railroad tracks, dumps, sewage treatment plants, prisons. Those things don't happen in the upper class wedge. I'm not necessarily talking about, if you drive in on an interstate, it's kind of like all interstates kind of look the same, but particularly if you drive in on the older roads where you're actually driving through the city. And you can drive into a city from one direction. So in this model, from the west. And you would say, wow, it's a nice place, nice suburban houses. You head into town, everything's neat and clean and nice shopping places, and maybe some mid-rises and some luxury condos and some nice older homes, and there's parks, and the zoo is there, and so on. Museums, all the nice stuff. And you drive and you say, hey, this is a pretty nice city. If you happen, that might be an example of that, would be the Northwest coming into Washington, D.C. on what's called Rock Creek Parkway in the Northwest D.C. It's all those things. Mansions, zoo, scenic road along a little creek, Rock Creek, jogging trails, and so on. You drive into the city, in D.C.'s case, from southeast, and it costs you get all the opposite. You say, well, this place is a dump. Sewage treatment plant, prisons here, dilapidated housing, shops with, steel bars across the liquor stores, all that stuff. So there's a lot of truth to Hoyt's sector model as well. Then Harris and Ullman came along and said, well, both Burgess and Hoyt get it wrong. Actually, the city is in neighborhoods or districts, I guess would be the best way to see it. They call it the multiple nuclei model, meaning multiple little centers. The textbook calls it Kino. Other places you may see it as described as the city's like a checkerboard. Once again, you have the central business district for all cities, but then you might have a warehouse district, a factory district, medium, a middle-income residential area, a high-income residential area, an industrial suburb, and so forth. And you think, well, there's a lot of truth, which I will show you in 1 second. I just wanted to say as well, I mean, there's a lot of interesting stuff that goes on within cities because they're always changing. Cities move, downtowns move, and indeed, geographers have talked about the central business district having zones of advance and retreat. They move toward the high income area because that becomes the higher rent district, luxury high rises, banks, financial things, fancy restaurants, higher end malls, jewelry stores, music stores, things that cost money to buy are on that side. And the city leaves behind, because it's moving, literally, rents drop, vacancies increase. Now, on this side of downtown, you have the opposite stuff. You have pawn shops, liquor stores with grates, metal grates across the windows. Goodwill will be here. Salvation Army will be here. The bus station will usually be there. Those types of things cluster in the area, in part because there's lower rent, because there's higher vacancies. Sometimes you might even have dilapidated buildings that nobody is, not just vacant. Nobody's ever going to rent it again, and things are just going to deteriorate over time. So, you're not going to put a fancy jewelry store there. So anyway, central business districts and downtowns aren't frozen over time. They move, literally can move in a certain direction. Downtown's moving out this way now, leaving that part behind. And geographers have called this, where it's moving, which is on the bottom right here, the zone of advance. That becomes higher rent. And then where it's leaving, the zone of retreat or zone of decay, and that becomes the lower rent side of town. Another example of that on a advance and retreat, and also an example of the Harris and Ullman multiple nuclei, or what are now called edge cities, also known as suburban downtowns. This particular picture is one of the earliest ones, one of the most developed over time. It's called Tyson's Corner. It's in Virginia. It's where Route 66, Interstate 66 meets the Washington Beltway, which is 495. And their sprawl, to some extent, folks who don't like sprawl say, well, the city's creeping outward. But these edge cities are also bringing back the idea of mixed-use development, meaning it is retail, it's employment and shopping and housing all in one place. And this is worth just talking about for a minute, because this is what creates sprawl, and this is what creates congestion. When you think of what we've done in the modern American landscape, right? We said, all right, we're going to build a very nice suburban neighborhood over here, houses on half-acre lots and so on and so forth. We're going to build 500 of them, whatever. And over here, we're going to make a nice shopping mall. And we're going to have all the box stores as well, the Best Buys, and they call those box stores, and the Walmarts and all those. And over here, we're going to have an office park and maybe some non-polluting factories where people will work. So you've segregated or separated your employment. You get people living in the housing development 8 miles over here, people living in the shopping mall 6 miles over here, people working 10 miles down here. So of course, people spend all their time commuting back and forth between where they work, where they shop, where they live. Mixed use development means, as is occurring in a lot of these edge cities, means they're planning for employment because you have office parks there. But they're also planning for residences. Now, maybe you can't, in this type of environment, I don't see any single family houses here, but at least you have condos and high rises and garden apartments, things like that. So people can live next to where they work, and they have shopping as well. So it's now possible to economize. Maybe, I don't know if it's fair to say you can bicycle around this area. I wouldn't want to try it. But, short commuting distances to get from where you live, where you work, where you shop. And it's really a return with the automobile and interstate highways. We get away from the idea. It's really a very basic idea. If you go back to 1850s Paris, right? People did not separate home, work, and shopping, right? You'd be right in the heart of Paris, and you go to the bakery to buy a loaf of bread. Well, there's the guys in the back, kneading the dough and baking the bread in the oven. And the family that ran it lived upstairs. So you had your residence, your shopping, and your job all together. Same thing with the butcher. They were butchering the chickens out back. The butcher shop was in the front of the store. The people lived upstairs. With the automobile, we got away from that. We started segregating these districts and saying, this is just housing. We're not letting a shopping mall in here, and we're certainly not letting a factory in here. We'll put all the factories down here. We'll put all the shopping over there. So it forced people to spend a lot of time commuting. So now, edge cities, also known as suburban downtowns, there are some of those nuclei or sectors on the Harris and Ullman model. Anyway, these mixed-use developments, or sometimes called planned-use developments, are bringing those things back together again. Shopping, residences, and employment. Another way the Harris and Ullman model is still correct, because just like there's some aspects of the rings that are correct, some aspects of the sectors that are correct, the wedges, and some aspects of the neighborhoods or districts. Ethnic and racial neighborhoods in cities are largely districts, or some of those nuclei, so to speak. We could put any city in the United States. This happens to be Chicago. And this particular map defines it as the areas that are more than 75% white, which are shown in this kind of yellow color. The areas that are more than 75% black, which are shown in the red, and the areas that are more than 75% Hispanic, which are shown in the gray. 3 different districts there. And it just shows that we still have these ethnic neighborhoods. You may still have a Chinatown. You may still have an Italian neighborhood in some cities, but they do tend to be blocks or districts. And it's not just the U.S. Here is London. London is, like New York, is one of the most ethnically and racially diverse cities in the world. Because London had colonies all over the world. Folks have come from those colonies all over the world to London. So you can go to London today and find these are the Asian communities, because remember, England colonized India and Pakistan, so you find their entire Indian neighborhoods and Pakistani neighborhoods. These neighborhoods over in this section tend to be the African folks from the Caribbean, like Jamaica, for example. But then they also had colonies in Africa, so they're African folks from Africa. And again, you can see that while some folks are integrated into the larger community, there still are these very distinct neighborhoods. You say, oh, that's the Pakistani neighborhood, that's the Jamaican community, and so forth. The sector, so we talked about ways that the sectors are, or wedges are correct, and the ways the nuclei or neighborhoods or districts are correct. An interesting thing about rings, the best way, well, there's some truth to what Burgess originally said. Higher income and lower income and so on. Actually, if you look at cities with computer, sort all this stuff out with computer programs, one of the distinct things about city is we'll call it the family cycle. Married couples who are going to have kids tend to be on the outer edge. They have kids or they're going to have kids. And of course, they're headed out more. It makes sense. They're more out toward the suburbs. Single folks, they're in college. They have their first job, whatever. They tend to be clustered toward the center of the city. And even what they call cohabiting, meaning folks living together, even at that stage, they start tending to move out a little bit, saying, well, we don't want to be right downtown. It's noisy, it's polluted, it's a lot of traffic, there might be higher crime. We'll move out a little bit. We'll get an apartment together and move out a little bit. Then when they get married, they move out to the farthest ring. And so the idea of this is people go through these rings through time, which is why you could call it the family cycle. So you're a kid, you're born, typical kid is born more out toward the suburbs, right? Then over time, they move in toward the center of the city, get their first job, they want their own apartment, they don't want to live in mom and dad's basement anymore. They want to move in the center of town, all the nightclubs are there and so on. Then later on, they themselves move farther out as they live with the partner and then get married. And maybe you even complete the cycle because in a lot of center cities, unless you go to one of these when you espouse, so you get married, eventually your spouse dies, one or the other, the man or the woman. Nowadays you can go to one of these suburban old age homes, but a lot of folks come back to the center of the city because you have very high percentages of elderly, sometimes unfortunately poor folks also concentrated in the center of the city. Now, because all that stuff is convenient, you can walk to it. Maybe you're too old to drive, so if you don't have family in the immediate area, you're going to walk, take the elevator down your apartment building, go across the street to get groceries or something, or go to a bar maybe or whatever. But the point is, sometimes single old people end up back in the center of the city. It's very difficult for elderly people to live in the suburbs. You can't live in the suburbs anymore once you can't drive, unless you're a millionaire and you can take taxis everywhere. But so those rings are correct in a sense in terms of what's called the family cycle, about how people move in and out of the different rings over time as they go through different stages of life. Being a kid, being single, being married, being elderly, so forth. And that's what this slide says. Cities, to summarize, cities have aspects of all three of those urban models. That the income and transportation corridors tend to be in the Hoyt's sectors or wedges. And you can identify high income wedges. Drove into this town, everything looks beautiful. Low income wedges, especially along industrial corridors. I drove in from the other side of town, looks like a dump. The concentric zone or model or rings tend to best describe population in the various stages of the family cycle, as we just talked about. And then thirdly, you do have things in blocks or districts. Ethnic and racial groups tend to be in districts. Industrial districts like a wholesale sector or manufacturing center or new industrial park, those tend to be in districts. Edge cities, you can think of it as a district. And another interesting thing, historically, every big city, no matter our stereotype about sometimes about, well, who wants to live downtown? Almost every large metropolitan area retains an island of very high income folks who, and because they're high income, they can protect that neighborhood. As I said earlier, they're never going to move a dump in there or a prison. They can afford security, so they have gates. They may literally have security. They have their, you know, parking is for them only. You have to have a permit to park on the street. You've seen these neighborhoods in big cities, and so there always is an island of high income in just about every city, no matter how rapidly the city has grown. And just some examples here, places that you hear about, like the Upper East Side in New York, or Beverly Hills in Los Angeles, or Beacon Hill in Boston, Nob Hill in San Francisco. And if you go back to Hoyt's sector model, and you see that high income wedge that extends all the way into the central city. And I think I'll stop there, since we've gone a little more than an hour. And we'll see an example of this. We'll pick up with this by looking at, again, I've focused on American cities. Now we'll take a look at some examples in like Latin America, for example, just this to show how things can be different from what they are in the United States.